Hello, welcome to Fundamentals of Acoustics. Today is the second day of the 8th week of this course. What we will do today is a continuation of our discussion which we were having yesterday. We had started discussing how using a wall which has a non-zero mass and which is free to move can be used to reduce the sound pressure level on the transmitted side. So that is the mathematics which we are trying, to develop, and in that process yesterday what we had accomplished was we had developed a relation for PB and UB in terms of P plus and P minus, where PB and UB are complex pressures for pressure and velocity on the transmitted side, and P plus and P minus are magnitudes of complex incident pressure and complex reflected pressure. So that expression has been shown here and it is numbered as 4. Now, so once we have done this, we have eliminated PT, and to get to the ratio of PT and P plus, we have to apply one more condition. So, and once we apply one additional condition, then we will be able to eliminate P negative also, and we will be able to get the relation between P plus and PT. So that is what we plan to do in today's lecture. One condition is what we have already applied, but then there is another condition, and the condition is that this is the wall, it is being incident, it is being struck. So the incident complex pressure is P plus E minus J omega x over C E J omega t. Reflected pressure wave in complex terms is P minus E minus J omega x over C E J omega t, and transmitted pressure is PT E minus J omega x over C E J omega t, and this term should be plus. Now, when this wall is being acted by pressure on the transmitted side and pressure on the incident side, because if the pressures are different, then this wall will move because it is free to move. So the motion of the wall how do we figure out what is the nature of this motion? It is equal to total force on the wall, and that is equal to mass of the wall times acceleration. Okay, mass of the wall times acceleration. So this is the equation we will develop. Total force on the wall is, so total force on the wall is sigma F, and that equals pressure on left side minus pressure on right side times area. So the pressure on left side is going to push the wall in the positive x direction, pressure on right side is going to push the wall on the negative x direction. So that is why I have a negative thing, and times area of the wall. So what is pressure on the left side? It is equal to incident pressure plus reflected pressure. So it is P plus E minus J omega x over C E J omega t. So this is on the left side incident component plus P minus E j omega x over C E j omega t. So, this is on the left side of the wall, minus P t E minus j omega x over C E j omega t times A. So, this is the sum of forces, and if I, so this is the complex pressure. So, when I add this up, it will be complex force, and this equals, so this is sum of forces, and then what is the right side? So, right side of this equation is mass times acceleration. So, this has to equal mass of the wall, and what is mass of the wall? It is m times A, because m represents mass per unit area. So, there is one more bracket needed, and then I multiply it by A. So, on the right side it is mass times acceleration. So, mass is m times A, where A is the area of the wall, times d ub over dt, and this has to be evaluated at x is equal to 0, and also right side also has to be evaluated x is equal to 0. Okay. So, what do I get? I get, when I put x is equal to 0 in this entire relation, I get P plus P minus Pt e to the power of j omega t times A, and that equals mass times mass per unit area times area. And what is UB? UB, we use this relation. UB is Pt divided by Z naught into e to the power of minus j omega x times e j omega t. So, it is e to the power of minus j omega x over c e j omega t, but then I have to differentiate it, and for differentiating I did not leave a lot of space. So, I am going to erase it and rewrite it. So, m a d over dt, this entire thing, and this also I have to evaluate at x is equal to 0, and there is of course Pt. So, what I get is so P plus P minus Pt e j omega t equals m a over z naught times Pt, and when I differentiate the term in the bracket, only this thing gets affected. So, I get j omega e j omega t, and this term becomes 1 when x is equal to 0. So, I am just omitting that out now, and then of course, there is an A. Huh? Oh, I am sorry. So, there is also an A here. So, A and A cancel out, so does e j omega t. So, I get P plus P minus Pt is equal to m over z naught j omega Pt, okay, which gives me now, so Pt into 1 plus m j omega over z naught, is equal to P plus P minus. Okay. So, this is another expression, or I can say that Pt equals P plus P minus times Z naught divided by Z naught plus mj omega. So, this is another expression for Pt. So, we had developed one expression for Pt which was from 3, Pt equals P plus minus P minus. So, we will rewrite that equation again. So, the other expression for Pt was Pt equals P plus minus P minus. Okay. So, if I equate these two, so if I equate the RHS of both of these equations, then what do I get? I get P plus minus P minus is equal to P plus P minus divided by Z naught plus mj omega. Okay. So, now this equation has only P minus and P plus. Okay. So, if I do the math for this equation, I can get the ratio of P minus over P plus. Okay. So, if I do the math, what I get is P minus over P plus is equal to j omega m divided by 2 Z naught plus j omega m. So, this is what we get. P minus over P plus is this thing, or P minus equals j omega m divided by 2 Z naught plus j omega m times P plus. But our goal is to find the ratio of Pt and P plus. So, what I do is I put this back in this relation. So, what do I get? Yeah. So, what I get is Pt equals P plus minus P minus, and P minus is j omega m divided by 2 Z naught plus j omega m times P plus. So, ultimately what I get is Pt equals, so I will write down the ratio. So, thus Pt over P plus equals 1 minus j omega m divided by 2 Z naught plus j omega m, and that equals 2 Z naught divided by 2 Z naught plus j omega m. Okay. Or finally, we can write Pt over P plus is equal to 1 divided by 1 plus j times omega m divided by 2 Z naught. Okay. So, that is my ratio. So, what does this say? What it says is, what this equation tells us is that as omega, so consider the fact that there is a wall with a fixed value of m, and if omega is extremely low, suppose omega is theoretically, let us say it is 0 hertz. If omega is 0, then no matter how heavy the wall is, m can be extremely heavy, but the ratio of PT and P plus will be 1, which means that if frequencies are extremely small, then even heavy walls will not be able to stop sound from propagating from one side to the other side. Okay. And as omega goes up, this PT over PM, it becomes less than 0. Why? Because the magnitude of PT over PM or P plus is equal to 1 over 1 plus omega m by 2 Z naught square, this thing. So, as omega becomes higher, this ratio becomes less than 1, and the higher I go up in frequency, the more efficient a wall becomes in terms of stopping the sound, becomes less efficient. So, that is the discussion I wanted to have today, and what we will do is tomorrow is continue this discussion, and we will also develop board plots for transmission of sound associated with this type of a situation. So, thank you, and we will meet once again tomorrow. Bye.